Discuss Thuri Day. Today again I'll discuss the electricity chapter according to ICSE syllabus class 8. So in my last video I stopped with the battery or the cell. I was discussing about this. So I'll start with that only and we'll get a revision on that. So there are different sources of electricity, that is the cell, that is the battery, or the main where the electricity is supplied by the local electricity board, then electric generator or a solar cell. All these are the sources of electricity. Okay, now what is a battery? It is a collection of several cells where a cell is the unit of a battery. So battery, the unit of the battery is a cell. Okay, and it is a collection of cells that make a battery. Okay, now it is a small source of electricity. This battery is a small source of electricity where electrical potential is produced due to chemical reaction providing current which remains constant with time. Okay, so it has electrical potential which is produced by the chemical reaction which is taking place inside the battery, inside the cell, which is providing current, okay, which remains constant with time, and this is known as direct current. Okay, where the current remains constant with time, that is known as direct current. Okay, the main and the electric generator that provide the alternating current. Okay, whereas alternating current changes its magnitude and polarity with time. In direct current, it remains constant with time, but in alternating current, it changes its magnitude and polarity with time. Then every electrochemical reaction has its limit of producing electric potential difference, that is anode and cathode. Two this electrodes are there, anode and cathode, and every electrochemical reaction has its limit of producing electric potential difference. Electric potential is difference is produced in the anode and the cathode. Okay, therefore what is potential difference? Potential difference is defined as the work done in moving a unit charge from one electrode to another electrode. Okay, it is the work done in moving unit charge, one charge, that is unit charge from one electrode to another electrode. The work done, that is known as the potential difference. Its unit is volt. Okay, its unit is volt and it is named after Alexandro Volta. Now, to achieve desired electric potential difference across the battery terminal, multiple number of cells are connected in series. That makes a battery. Okay. So, to achieve, to get desired electric potential, how much electric potential we need, that desired electric potential to produce that across the battery terminals, number of cells are attached in series. They are connected in series. Okay, and these makes a battery. Now nickel cadmium cell normally develops 1.2 volts, okay, per cell, whereas lead acid cell that develops about 12 volts per cell. Therefore a 12 volt battery will have total 6 number of lead acid cells connected in series. Okay, then cells are connected in series, parallel, or in combination of both. Okay, cells are connected in series, parallel, or in combination of both. So in series, if they are attached, if they are connected, the cells are connected, then from the positive terminal, current will flow to negative terminal. Then EMF or electromotive force or potential difference is equal to cell plus cell. That is EMF, E is equal to E1 plus E2. If there are number of cells like E1, E2, E3, E4, that will be summation of all the electromotive force. Now what is electromotive force? Electromotive force is the maximum potential difference between the two electrodes of a cell in open circuit. When the circuit is open, that time, that is when the current is not flowing. Open circuit means current is not flowing. During that time, what is the maximum potential difference between the electrodes of the cell? That is known as electromotive force or EMF. Okay, and potential difference is the difference between 2 points in a closed circuit. Okay, that is the main basic difference between EMF and potential difference. EMF is that is the differential difference in the open circuit, and potential difference PD is the difference between 2 points in a closed circuit. Now, overall discharged current of a battery is equal to discharged current of the individual cell. Okay, now PD, that is potential difference, which is its unit is volt, and work, I mean V, it is denoted by symbol V, and work done W, and charge is Q. Okay, so PD, that is V, is equal to W by Q, or Q is equal to current, charge is equal to current by time, that is I by T. Therefore, current, we can say that it is charge by time. Okay, current is charge by time. Okay, now therefore current is the rate of flow of charges in unit time, that is known as current, and its unit is ampere. Okay, which is named after this ampere is named after Henri Marie Ampere, and it is denoted by capital A. Therefore, Q is equal to IT and W is equal to VQ. Therefore, W is equal to VIT. Okay. Q, that is charge, that is equal to product of, that is I, current into time. Okay. Charge is equal to current into time, and W is equal to VQ. Okay, that is potential difference into charge. Therefore, W is equal to VIT. Okay. I'm sorry, the current I will be is equal to charge into time. Okay, and it's not by time, but it's charge into time. Okay, so W, electrical energy supplied by battery or main in providing the current for time t in the conductor under a potential difference V. Okay, W, that is electrical energy, okay, that is work done or electrical energy which is supplied by the battery or the main in providing the current I for time t in the conductor under a potential difference, that is V. So power is the rate of doing work, and its unit is watt. Okay, so power is equal to W by T, that is work done by time or electrical energy by time. What is the energy by time? Then that W is equal to VIT. So VIT by T, or you can say VI. So power is equal to potential difference into current, and 1 watt is equal to 1 volt, that is potential difference 1 volt into 1 ampere. Okay, suppose a current flows through a conductor of resistance R for time t when a source of potential difference V is connected across its ends. Okay. Now from the above example, battery is equal to, which is I told you, that is they are in cells in series. Internal resistance, if there are internal resistances, because when the current is flowing, it has to pass through some resistance, internal resistance. Okay, so if the internal resistance in the cell 1 is R1, so R1 is present in cell 1, and internal resistance R2 is present in cell 2. So R, that is total resistance, external total resistance will be R1 plus R2, and if there are n number of cells, then R1 plus R2 plus R3 plus R4, like that Rn. Okay, so this is the series. If they are connected in the as they are connected in the cells are connected in series in the battery, so it will look like this. Okay, and the resistance will be looking like this, and E is equal to C, E1 plus E2 plus E3, like that En. Okay, and R also R1 plus R2 plus R3, like that it will be Rn, number of resistances. Next, transmission of power from the power generating station to the consumer. The electric power is generated at the power generating stations. There the electric power is generated from the power generating stations, and from there the electric power is generated at around 11 kV, kilovolt. Okay, so power which is generated, electric power which is generated from the generating stations, power generating stations, that is equal to 11 kV. Now, the voltage which is generated has alternating frequency of 50,000 hertz, and its polarity at the terminal changes 100 times a second. Okay, it's so as it is alternating current, so it will change its polarity at the terminals around 100 times per second. Okay, and 50 times it will be positive and 50 times it will be negative. Now the voltage is first raised from 11 kV to 132 kV. So the power which is generated from the powering stations, power generating stations, that will be 11 kV. That is voltage, that is 11 kV, and it will be raised first from 11 to 132 kV, so that loss of energy is reduced, while transmission, which is due to the heating of live wires, and then it is transmitted to the grid substation. Okay, then it is transferred to the grid substations. Okay, now their voltage will be reduced from 132 to 3 kV. That is, first it was 11 kV, then it is raised to 132 kV, then it is supplied to the grid station. There the voltage is reduced from 132 to 3, then sent to the main substation. It is reduced to 11 kV. Okay, and then the power is supplied to the substation, further reduced to 220 kV. Okay, and this way then it is supplied to the consumer. Okay, so this way this power generation, there's the power generating stations, they supply it to the consumer. Okay, so I'll stop here. I'll continue with the rest of the chapter in my next video. Please go through this. If you have any doubt, please do write in the comment box. And if you are liking the videos, press the like button. You can also give suggestions if you are not liking it and how to improve my videos. Okay, and please do subscribe as well as share with your friends so that they can also be benefited from these videos. Okay, and I'll be launching a website soon which will contain much more information on your subjects and different other subjects. Okay, so please wait for that. Some interesting facts are also there. And thank you for watching. Thank you.